Hello everyone. I hope you had a very nice day. My name is Ishan Mitra Haldar. My matric number is 201390.
Hello, my name is Nofari Simon bin Nuraimi. My matric number is 203243.
Today we are going to solve a little tricky integration question, and I hope you all will like the way how we all solve this one. And for your interest, we have a little surprise prepared for you all in the last part of the video. So stay tuned and I hope you'll enjoy the video. So let's get started. The question we have chosen is summation of x cubed sin x cos x dx. For this question, we will need three major things, three major equations to be precise. The first one will be the easiest one, like d dx of a to the power n equals to n a to the power n minus 1. And the second one we will need will be sine twice x equals to 2 sine theta cos theta. And the third one we'll need is the most important one. It will be summation of uv dx equals to u summation of v dx minus d dx of u summation of v dx whole dx. So these will be the three major equations we will apply to solve this question. So let's get started. First of all, we'll want to make this version like this one because we actually don't have any equation consisting u, v and w. So we'll just try to make it u and v. So you can see that we have placed an extra 2 in here, and to minimize the extra part, we have also divided the whole thing with 2. Now if you see, this one is representing this one, so we can't make it into sine twice x. Now this is the u portion and this is the v portion for this equation, and we'll apply this equation to solve this one now. As you can see, we have considered x cubed as u and sine twice x as v, and thus following this equation, u summation of v dx, then integration of d dx of u, integration of sine twice x dx, and whole dx. I hope you know that sine twice x actually when integrated, it converts into cos twice x divided by 2. And for this one, it is actually similar to this one, and thus it will be 3x squared. The summation part, we will actually solve it in this line, so it will convert into cos twice x divided by 2 and whole dx. But for sin x, there will be an extra minus in front of cos. see, this minus and this minus, as we all know, negative and negative actually makes positive. If you see this bird, it again actually made something like the similar one, that is uv. If we consider this as u and this as v, we can again apply the uv method to solve this portion. We'll just simplify this one first. We have only simplified this portion just by multiplying this part to these whole two parts. Again, we are applying uv method for this portion. We are considering this one u and this one v. So we only applied the UV method to get this line. If we integrate cos twice x, we will get sin twice x divided by 2. If we differentiate x squared, we will get 2x. And if we integrate cos twice x, we will again get sin twice x divided by 2. And these two can be eliminated. Now we will just multiply this two portion with this part. As you can see, this part has again become something like uv with the integration sign, and we again have to apply uv method to solve this one. So for this one, we only applied the UV method to solve this part and make it like this. We will multiply this part to the both parts to make it simpler. Sin twice x will become cos twice x divided by 2, and don't forget that there will be a minus sign in front of it. If we do the differentiation to x, it will only become 1, as there is only x to the power 1 in this part. And if we do integration in sin x, it will again become just like this, minus cos twice x divided by 2. sorry, I forgot 3 by 4. And then we are approaching our answer. For this part, we can see that 3 by 4 into 2, this will become 3 by 8. And cos twice x. So as you can see, these two gets multiplied with this one and becomes 3 by 8, and this minus sign with this minus sign becomes positive sign in front of it, and we have to integrate only this cos twice x again because there's an integration sign here, and as there's nothing to take as u, we don't have to bother to apply the UV method again. So our answer will be something like this: negative 1 by 4 x cubed cos twice x, positive 3 by 8 x squared sin twice x, positive 3 by 8 x cos twice x, and lastly for this part it will be 3 by 8 and the cos twice x will become sin twice x divided by 2, and as you can see these two will get multiplicated, these two will be multiplicated with 8, and our final answer will be this should be our final answer. Okay, for this part, I think I have made a little mistake. See, in this part there's negative and also negative, so negative and negative should be positive in this place. And when there's again positive and negative, this part will become negative. Yes, so this is our final answer, and as you can see, even I am having a lot of problems to solve it in this general method because we are actually applying UV method over and over again, and it is actually kind of making us very as you can see, this UV method is actually making us very confused, and also we are making mistakes like this one, and if we make this kind of mistakes in the examination, our teachers will obviously not give us the full mark. So now my friend Faris will come and show you the magical part I was talking to you about in the first part of the video. I hope you like his method.
Okay, so this is the question. Integrate x cubed sin x cos x dx. So from the previous method, we know that we can change it to half integration of x cubed sin 2x dx. So from this method, we have to make a table, 4 table. So for the first box is for derivatives. The second one is for integral. The third one is for sine, and the last one will be for product. So for derivative part, we choose the x cubed, and for the integral we choose the sin 2x. For the sine and product for this line, you can ignore it. Okay, so for derivative, we derivative the first one will become 3x square, and integral of sine 2x will become negative cos 2x over 2. And for the sine, we will put positive. So for the second derivative, it becomes 6x, and this will become negative sine 2x over 4. And for the sine, we put negative sign. And again, this derivative, we will make it until it becomes 0. So the next derivative will become 6, and for integral, it become cos 2x over 8. And for the sine, we put positive. So the next one will become 0, and this is the last derivative. For integral, become sine 2x over 16, and the sign will be negative. So for the product, we will multiply these things to become this. So for this box, it become negative x cube cos 2x over 2. So for the next box is the same, this one. So negative and negative become positive. So 3x squared sine 2x over 4. Same one for the next box. For here, 6x cos 2x over 8. And for the last box is this one. So negative sign, 6 sine 2x over 16. So for this one and this one, we can simplify it into 3 over 4 x cos 2x and negative 3 over 8 sine 2x. So for the whole thing, for these things, we can write as half this thing, and then the integration this into negative half x cube cos 2x plus 3 over 4 x cube sine 2x plus 3 over 4 x cos. Okay, so for this one, we write the whole thing. This is 1 over 2, and the integration of this thing, we can get this one, negative half x cube cos 2x plus 3 over 4 x square sine 2x plus 3 over 4 x cos 2x minus 3 over 8 sine 2x. So we can simplify it as 1 over 4 x cube cos 2x plus 3 over 8 x square sine 2x plus 3 over 8 x cos 2x minus 3 over 16 sine 2x. So this is the answer. Same as the previous method, this is the answer. You can compare it and you will get the same answer but simpler method. Okay, for this type of question where you have U and V, there are more than one method to solve this, and using this type of method is the simpler one, and I guess you can solve it really fast.
And without any mistakes.
Okay, so for this question, this is a indefinite integral question, whereas there is no limit. So for the answer, this answer is the general answer for the question. To represent the specific answer of the question, you have to add plus c, the constant of the integral. And the answer for the previous method is also plus c. So for the question for indefinite integral, you must put plus c for the last answer.